Hello students, how are you all? I am sure you are doing good. So here in the board you are seeing a graphical representation. So this is a graphical representation of the electrical activities in the human heart. So in my last video I had also discussed about the generation and your conduction of the action potential or the electrical impulse. But in the video, I had addressed this portion as a chapter from class 10. But actually, it is not a chapter from class 10, it is for the class 11 CBSE students. By slip of tongue, I had said class 10. As far as syllabus is concerned, it is for the class 11 CBSE board. So, with that, I am starting this portion of this very important chapter. In fact, you have seen the monitoring machines in the doctor's chamber and also in the hospitals, which are making sounds like peep sounds and also continuously peeping. So these are the monitors which are doing what? Which are recording graphically the electrical impulses or the action potential in the heart. Okay, so how it is done? The machine, the monitor is called the electrocardiogram, and two electrical leads are attached to the persons or to the patients, both the wrists, attached with both the wrists of the person, and one electrical lead is attached to the left ankle of the patient. Now, what the machine will do, in the graphics, these are the symbols which are denoting or depicting the peaks. Okay, this is a peak P. This is also a complex, that is QRS, showing a peak, and also a peak T here. So the first one, which is the P, is actually the depolarization of the auricles, causing the auricular systole, So this is the first depolarization which is taking place in the auricles, and then this the action potential is conducted to the ventricles, and there also depolarization takes place. That means systole in the ventricles also. This is shown, this starts from the point Q, and this is the complex QRS, the systoles, the ventricular systole, right? Now, slowly again, the ventricles will come back to their normal position, right? Gradually, and that is shown by T. Here the systole will end, the ventricular systole will end, and this peak will also gradually end. Again a new cycle will start. So what actually it is doing? It is showing the QRS complex, that means the ventricular systole, okay? And now, when the number of QRS complex is seen, is noted, then naturally the heartbeat of a person can be determined in a given period of time. That can be determined. So, this is seen and compared with the other ECGs of the different people in the same lead configuration. In the same lead configuration it is seen, and if there is any deviation, that means there is an abnormality or a disease in the person's heart. So accordingly, that condition of that disease can be treated, and that is why this is so significant. Clinically, this is very, very significant, this electrocardiograph. Okay, so this you have to understand, this you have to remember. Some questions can come, and this will also help you in your further studies to have an idea about the ECG. So, students, I think this is the explanation of the ECG, and I am repeating again that the peak T, the T wave, these are the waves they're represented by the symbols. So T wave represents the return of the ventricles from excited to normal, from depolarization state to the normal state, which is called the repolarization. If you remember the conduction of the impulses, okay, wherever there is a stimulus. But here there is no stimulus. External stimulus is not there, right? This is the difference. So in the normal transmission of impulses, nerve impulses, firstly depolarization takes place, right? First is polarized state, that is the resting state, then depolarization takes place, and then again repolarization state takes place. So here also, the waves, the T wave marks the end of the systole. The T wave marks the end of the systole, or repolarization is taking place here. So it will come back to its normal position, and the wave will end. Okay, the end of T wave marks the end of systole in the ventricles. So like this, it is compared, and the number of QRS complex is noted, which will determine the heartbeat of that patient. And if there is any deviation in this graphic representation, then it will indicate to certain disorder or certain abnormality in the person's heart. Okay, so it is compared with the the ECGs of other different people in the same lead configuration, right? So students, I am ending here, and if you ending the video here, and if you really like my videos, please subscribe to my channel, and if there is any question or any query, please let me know in your comment section. Please write about any specific portion that you want me to explain, or any answer of any question regarding your chapters or any part of the chapters from your syllabus. So with that, I am closing this video here, students. I will come back with some other important videos which will naturally include the important portions from your chapters. Thank you very much. God bless you all.